Hello friends, in this session we are going to discuss classification of quantization. So, based on the classification, quantization are of two types. First is uniform quantization and second is non-uniform quantization. In uniform quantization, output that is called representation level have equal step size. But in non-uniform quantization, step size are not equal for representation level. Now first, we discuss uniform quantization or quantizer. In uniform quantizer, step size S remains constant throughout the input range M. And the characteristic of uniform quantizer is described by a staircase function of equal steps. According to this, uniform quantizer is classified into mid-tread and mid-rise. That is shown in figure. Here the staircase function is represented on output level versus input level. In mid-tread, origin lies in the middle of a tread on the staircase. In this, each tread or step size are equal. So, at the origin, the tread having input level from minus s by 2 to s by 2. And accordingly, we have input levels plus minus 3s by 2, plus minus 5s by 2, etc. And at the output level, that is called representation level, step size mark as plus minus s, plus minus 2s, plus minus 3s, etc. Similarly, in mid-rise, origin lies in the middle of the rise of the staircase. Here, origin lies in middle of a riser. So in this case, output level is scaled with plus minus s by 2, plus minus 3s by 2, plus minus 5s by 2, etc. And input levels, that is called decision threshold, is marked with plus minus s, plus minus 2s, etc. In both cases, quantization error versus input level is characterized by sawtooth wave. In mid-tread, we have ramp signal with positive unit slope, and in mid-rise, there is negative unit slope. And accordingly, maximum quantization error is equals to plus minus s by 2. But there is a problem with uniform quantization. Uniform quantization is not efficient for practical point of view, such as telephone communications, speech signals, music signals, etc. So in this case, we study non-uniform quantizer. In these practical examples such as telephone, speech signals and music signals, there are various voltage levels including small as well as large amplitudes. And due to this, signal to noise ratio is disturbed. And in order to improve signal to noise ratio, the step size S varied according to the different signal levels. So here, non-uniform quantization is applicable. So, in non-uniform quantizer, step size is a variable parameter and generally used in telephone communication system. Non-uniform quantization is practically achieved through a process called compending. The compending word is a combination of compressing and expanding. Compressing at the transmitter side and expanding at the receiver. So, at the transmitter side, modulating signal MT is passed through compressor and the output of the compressor is a compressed signal having uniform step size. And now we can use uniform quantization for the transmission of coded signal. Now at the receiver side, this transmitted signal get decoded and then passed through expander. Expander operates just inverse of compressor and act as a nonlinear device. So, after decoding and expanding, we recover original modulating signal MT. This compounding process having a characteristic that is represented by output voltage versus input voltage. Here, the solid line represents compression and dotted line as expansion. And it is observed that due to inverse nature of compressor and expander, the overall characteristic is linear. Also, at the receiver side, signal is expanded, exactly opposite to compression, in order to recover original modulating signal empty. Now we discuss compression law. In non-uniform quantization, the compressor is based on the compression law at the transmitter side. These are called mu law and A law. Mu law is used in US, Canada and Japan, while A law is used in Europe. So first we discuss mu law. According to mu law, mod of V is equals to log 1 plus mu mod M upon log 1 plus mu, where mod M and mod V are normalized input and output voltages and mu is any positive constant. Practically its value is near about 255. And when we plot mu law on the input output voltage characteristic, that is mod V versus mod U, we have some observations. When the value of mu is equals to 0, we have uniform quantization. But when value of mu increases, we get nonlinear characteristic that represent compression process. Next compression law is A law, and it is expressed as mod V equals to A mod M upon 1 plus log A for mod M greater or equals to 0, less than or equals to 1 upon A, and mod V is equals to 1 plus log A mod M upon 1 plus log A for mod M greater or equals to 1 upon A and less than or equals to 1. Here, the practical value of A is near about 100. And after plotting A law on input output voltage characteristic, we get uniform quantization for A equals to 1. For A equals to 1, expression of mod V is equals to mod M, because log 1 is equals to 0, and we get linear characteristic from 0 to 1. This is also confirmed by second expression, that is when A equals to 1, we have 1 plus log mod M upon 1, and here the value of mod 1 is equals to 1. So we get mod V equals to 1 at mod M equals to 1. And as the value of A increases, the curve become nonlinear, and that represent compression process. These compression law can be used to determine the step size in quantization process. The reciprocal slope of the characteristic curve define the step size. For this, we first determine the slope, that is d mod V upon d mod M. In case of mu law, the slope is equals to 1 upon log 1 plus mu into mu upon 1 plus mu mod M. And its reciprocal, that is d mod M upon d mod V, that is step size, equals to log 1 plus mu upon mu into 1 plus mod M into mu. Similarly, slope of A law is expressed by d mod V upon d mod M equals to, first is A upon 1 plus log A for mod M greater or equals to 0, less than or equals to 1 upon A, and 1 upon 1 plus log A into A upon A mod M for mod M greater or equals to 1 upon A, less than or equals to 1. Here A is cancelled. And after taking reciprocal slope, we get step size, that is d mod M upon d mod V equals to 1 plus log A upon A for mod M greater or equals to 0, less than or equals to 1 upon A, and mod M into 1 plus log A for mod M greater or equals to 1 upon A, less than or equals to 1. So by using reciprocal slope, we can determine the step size. And both A law and mu law compounding is used for pulse code modulation telephone system.